Hey there, Bill here. Hoping you're having a good day, guys. So, without further ado, let's get into it. Now we have to do. Let's get started.
All right, this is CS50's Introduction to Programming with Python. My name is David Nalen, and this is an introduction to Visual Studio Code for CS50. Visual Studio Code, or VS Code, is a very popular program nowadays for writing code. It's technically a text editor, or nowadays really an IDE, an integrated development environment, which means it's a program that's designed for enabling you efficiently and effectively to write code in your computer. Now, it turns out you typically install VS Code on your own Mac or PC. It's free open source software, which means anyone can download it on their own computer. But typically when installing it on your own computer, particularly to use for programming with a language like Python, there's a few other steps as well. You need to install support for Python itself. You might need to configure some of the lower level implementation details of your computer just so that things work. And so instead for this course, we recommend that you use VS Code, yes, but you use it in the cloud by way of CS50's own implementation thereof on top of something called GitHub Codespaces, which is a hosted version of the same. To use Visual Studio Code for CS50, go to code.cs50.io, where you'll be prompted to log in with your free github.com account. After some number of seconds or minutes, you'll then be redirected to your so-called code space, which is your own virtual space in the cloud. Somewhere out there on GitHub servers, you will have access to your own storage space, really your own hard drive in the cloud, in which you can create files, run programs, and even organize everything in folders. You'll also have the ability to write code via that interface and much more. The interface you'll see typically looks a little something like this, whereby you'll have at the top left hand of your screen a file explorer that allows you to see all of the files you've created over time in your account. You'll then have the ability at the top to actually write code by creating one or more tabs in which to write your programs. And then perhaps less familiarly, at the bottom of the screen, you're going to have access to what's called a terminal window. A terminal window is a command line interface, or CLI, which is very much in contrast with what you and I are mostly familiar with nowadays, which is a graphical user interface, or GUI. Indeed, everything we're seeing here is graphical by nature. There's buttons and icons and windows and more, but underneath the hood, you actually have access not only to your own virtual hard drive in the cloud, but actually your own server too. Somewhere out there on GitHub servers is your own server in a sense, your own virtual server, or technically called a container, in which all of your own files will live. You then have the ability to create files, run programs, even install additional software within that server or that container, because that server container is itself running its own operating system. And the operating system it's running is not Mac OS or Windows, with which you're probably familiar, but another popular operating system called Linux. And Linux is used by so many programmers and more nowadays, not only to write code, but to run it on their own servers as well. So how can you go about leveraging this new command line interface? Well, it's worth learning just a few commands that you might not have typed previously. These commands work not only in Linux, but also on Mac OS, and also with some modification potentially on Windows as well. But if you're using Visual Studio Code for CS50 in the cloud at code.cs50.io, you'll have the ability to run all these commands and more. And here is just a few of those that you can type. I'm going to go ahead now and type code, which actually is a command that comes with VS Code itself that enables me to create new files and open new tabs. I'm going to change screens over to my own computer here, in which I have full screen VS Code for CS50. So this is my browser window full screen connected to my own code space, my virtual container in the cloud. And suppose that I want to go ahead and create my own first program called hello.py, a program written in Python. In my terminal window, I could type code hello.py and hit enter. But before I do, notice at top left in my so-called file explorer, there's technically nothing there. There's some mention of code spaces and some mention of my own unique ID, but there's no actual files or folders there yet. But when I hit enter, thereby creating a new file called hello.py, I'm not only going to see it up here in just a moment in a tab where I can edit it, I'm also going to see a graphical representation of it up here, which is only to say that this environment, this integrated environment, all works cohesively. Here we go, hitting enter. My tab has opened, my prompt is blinking here so I can start writing code, but you'll also see that hello.py not only exists, but is highlighted as the file I've opened. Well, let me go ahead and write a very simple program now. Print, quote unquote, in parentheses, hello, comma, world, which, as you'll see, if not already, is perhaps the most formative, most canonical program you can write first when writing code in most any language. I'm going to go ahead now, and in my terminal window, I'm going to run one other command that you'll learn all the more about soon too. I'm going to run Python itself, which is not only a language, it's actually a program that understands that language. And if I specify not just Python, but a space, and the name of a file that I've created containing code written in that language, crossing my fingers as always and hit enter, I've just run my own program. Now on our Macs and PCs, we're generally in the habit of pointing and double-clicking on icons, or on our phones, tapping on icons to launch some file or program. In a command line interface, or CLI, everything is done with the keyboard. You can use your mouse to move your cursor up and down as needed, but generally you do everything with your keyboard, not really with your mouse. Everything else on the screen can be clicked on, but in your terminal window, you'll generally see this prompt. A single $sign that does not mean dollar or currency for that matter. It's just a standard symbol that means type your commands here. And it's a visual indicator that you can type your next command. And indeed, the two commands I've just typed are code to create my new file within VS Code itself, and then Python, which we, CS50, already pre-installed into your code space so that you have built-in support from day one with writing your own code. Now, there's other things I can do in this environment. I, for instance, could control-click or right-click up here and see a whole menu of options with which to edit or modify that file, just like on Mac OS or Windows. I could click on some of these icons at top left, the plus icon, to create a new file or a new folder. So all of those GUI conventions, graphical user interface conventions, are still there, but you will and should get more comfortable over time with the command line interface alone, which does all of those things and more for you. In fact, here are just a few more of the commands that you can use within Linux and this command line interface specifically. We'll see in a moment ls, which allows you to list all of the files in your current folder. CP, which will allow you to copy a file from one place to another. MV, which will allow you to move a file or really rename it from one name to another. RM for remove, which will allow you to delete a file. Mkdir, or mkdir, which will allow you to make a directory, that is a folder. CD, which will allow you to change directories from one folder to another. rmdir, which will allow you to remove a directory. And then clear, which will just aesthetically clear your terminal window if, like me, you like to keep things a little bit tidy. Now, these are just some of the commands you can type within Linux at this command line, but they're really equivalent to all the kinds of things you and I already do frequently on our own Macs or PCs. Let me go back to VS Code here, and let's just try out a few of these here. I'm going to go ahead and first clear my screen, as though we're starting from scratch, but this doesn't change or delete any of my files. It just clears my terminal window. I can alternatively hit Control-L to do the exact same. Now I'm going to go ahead and type ls, but before I hit enter, note that ls kind of sounds like list, and indeed this command and almost all of those others were fairly succinct in that ls means list, but you only type the L and the S, no list. And this is true of a lot of command line interface commands, just to enable you and I to type things more quickly. A lot of these commands have this very succinct syntax and names. So here we go. I typed out ls already. I'm going to go ahead and hit enter, and you'll see only one thing, hello.py, which is to say when I try to list all of the files in my current default folder that just automatically opens when I launch VS Code in the cloud, I only see the one file exists, which I can also see graphically here. Well, let me go ahead now and do something else. Let's make a copy of this file and call it goodbye.py, just so in anticipation of writing a second program that says goodbye world instead of hello. I'm going to do cp for copy, then the first name of the file, hello.py, then a space, and then the new name for the new file, goodbye.py, enter. And now notice nothing really has happened. That's generally a good thing. If you don't see an error message down here, you've done well. But you do see graphically up here that both files now exist. Now I could open goodbye.py in a couple of ways. I could actually just go up here and double click on goodbye.py to open it here, or I can type the same command as earlier, code of goodbye.py, and now I'll have a second tab open here. And for parallelism, I could change this word from hello to goodbye, just so I have a second program now that is indeed the second file as well. Now, what if I decide that I don't want this file, and I'm going to go ahead and close it here, and I want to rename it and change it to from goodbye.py to farewell.py? Well, it still says goodbye.py up here, and if I type ls down here, I'll see a list of 2 files now that are in that same folder. Let me do mv for move, goodbye.py, and then something like farewell.py instead, enter. And you'll see that it changed up here at left, and if I type ls again, you'll see that it changed down here as well. Well, you know what, let's never mind with farewell.py. Let's go ahead and just remove this file altogether. I could go up here and single click on farewell.py in my file explorer, control click or right click, and then select delete. Or down here in my command line interface, I could do this. I could do rm space farewell. And now notice, if I'm a little tired of typing out these long file names, Linux and command line interfaces frequently support autocomplete. So instead of typing farewell, I'm going to type far, which sounds like more than enough characters to finish the rest of my thought, and I'm going to hit tab on my keyboard, and it just finishes it for me without having to manually type the same. I'm going to go ahead and hit enter, and I'll see a somewhat cryptic message now, as many of them admittedly are. It's not an error, it's just a prompt. Remove regular file, quote unquote farewell.py. This is just a safety check to make sure that I'm okay with deleting this file. Generally, when prompted with a question like this, go ahead and type in y for yes or n for no, and hit enter, and now nothing bad seems to have happened in terms of any messages, but indeed, farewell.py is now gone. Well, what more can we now do? Let me clear up the screen just for aesthetic's sake here, and let's create one or more folders, not just files. Let me go ahead and make a directory here with make dir, and let me just call it folder, though I can call it anything I want. Alternatively, I could go up here to my file explorer, click on the plus icon here on the folder, and manually create a no folder as well. But here again, the goal is to focus on this command line interface instead. All right, make dir folder and hit enter. Nothing seems to happen in the way of error messages, but now notice there's not just hello.py, but a folder or directory called folder. Well, what now can I do with that? Well, let me go ahead and see what's inside. Well, in my GUI, my graphical user interface, I could click on the folder here in this little triangle and look inside, and of course there's nothing there because I literally just created it. But let me do this now in my terminal window. Let me type ls after clicking down here, and we'll see both my folder, which by convention has a slash at the end to make visually clear that it's a folder, not a file, and there's hello.py. Let me go ahead now and change directory. Now in macOS or Windows, we would again just click or double click on the folder and see what's inside. In a command line interface, you need to be more deliberate. cd space folder, with or without the slash is fine, and then hit enter, and now you'll see that your prompts change. There's still a $sign, but by convention, and this is a CS50 detail, though other people do this too in the world, we have prefixed your prompt with a just quick reminder of what folder you're in, so that you don't forget whether you're in your main folder where you began or some other folder therein. I'm going to go ahead now and type ls to list the contents of this folder, and of course there's nothing there because I haven't created any files. But if I do this, I could do code of farewell.py again to bring it back, but this time in this folder. Hitting enter, you'll see a new tab opens here where I can write some more code, but you'll also see hierarchically here the farewell.py is now inside of this folder. Now suppose this is a mistake and I didn't mean to do that. What can I do? Well, let me close the tab here even without writing any code, and down in my terminal window, let me do this. I'm going to type ls to confirm that, yep, farewell.py exists there, but suppose I want to move it into my main folder. Well, like on macOS or Windows, I could click on the file here, farewell.py, and just kind of drag it up or down to put it where I want, but let's move it. Not rename it this time, but move it using that same mv command instead. I want to move farewell.py to the parent folder. In the world of files and folders, you can think of things like a family tree. And if you want to go up hierarchically, you want to go into the parent folder, so to speak, whereas folder is conversely a child of the default folder in which we began. So I want to move farewell higher up. How do I express that? Well, another piece of syntax in a command line interface is typically this, dot, dot. Dot, dot is a symbolic representation of whatever the parent directory is, no matter what its name is. In this case, it's my own default folder. Doesn't even matter what its name technically is. It's not pictured on the screen. I'm going to go ahead and hit enter, and watch what happens at top left in the graphical version of the same. We should see that farewell.py now pops out of the folder, and the indentation changed to imply that it's not inside of the folder now, it's alongside hello.py. Indeed, if I close the folder here, I don't see a difference because there's nothing in there as well. Let me type ls to confirm in my terminal window. There's nothing in folder. Let me now go back to my parent directory, and I can do this in different ways. And like with programming itself, there's going to be many ways sometimes that you can navigate a command line interface. Here's one. I can do cd for change directory, and then space dot dot to go back to the parent directory. But another technique, especially if you're a little less comfortable with this whole new world, is whenever in doubt, if you want to go back to your default directory in which you began when you logged in, just type cd with nothing after it and hit enter, and you'll be whisked away back to the starting point. Indeed, if I type ls now, I'll see farewell.py, my folder, if empty, and hello.py as well. Now, I don't really need this folder because there's nothing in it anymore, so let's go ahead and delete that. I could click on it with control click or right click in the file explorer, and I could delete it manually like in macOS or Windows, or I can use my newfound commands, rmdir for remove directory, space folder, with or without the slash, and hit enter, and because it's empty, I'm not even prompted, it just goes away quite cleanly. And a final technique that you'll find quite helpful in the context of a command line interface is that it tends to store your whole history of commands. In fact, not just autocomplete, but if I hit up and up and up and up, you'll see my history of all previous commands scrolling up on there on the screen, which is helpful if I just want to execute one of them again. I don't need to manually type it out. I can scroll up and down and find the one that I want. So this then is just a scratching of the surface of a command line interface in the context of Visual Studio Code in the cloud. Most of these commands would be the same whether on your Mac or PC, at least if you're using a terminal window that's connected to a computer running Linux, be it a container or a virtual machine or an actual server somewhere in the cloud. In the weeks to come for this class, will you have access to code.cs50.io and in turn your own code space so that you have access 24/7, 365 via a browser alone so long as you have internet access without needing to install anything on your own Mac or PC. Toward the end of the semester, if you're feeling more comfortable and would like to use the same software, VS Code, if not Linux as well, you'll be able to also install those for free on your own Mac or PC and continue programming onward even after the course's own end. This then was Visual Studio Code for CS50 and with it a command line interface, and this is CS50 itself.
Okay, so in a moment, we're going to write a very simple program, and while we do, we're going to think about what a program actually is at the end of the day. So we've seen so far that we have this language called Python, and we can use Python to write programs. And Python itself has all these tools at our disposal to actually write those programs with. So among them are things like conditionals, variables, loops, and in this case, importantly, functions, where a function is some piece of code that kind of takes an input and produces some output. You can think of kind of like a verb that you can actually run inside of your own program. So here, I'll go ahead and make a program called hello.py. I type in code hello.py, and I'll hit enter, and I'll get this blank Python file. I know because it ends with .py here, and I want to call or use my very first function. And one function built into Python is called the print function, where the print function takes some text as input and produces as output this text in my terminal down below. So I'll type print here, and I'll follow it with parentheses, just like this, and I'll type hello world, like that. So now I've used or called my very first function, print. And maybe afterwards I'll also type print, maybe this is CS50P, like this. So now I have a very simple program, and I've, in this case, used two functions. Now, if you're new, you'd be asking, how do I know that these are functions? Well, it just so happens that functions have these identifiers you can use to determine when you're actually looking at a function. Now, one of these identifiers are these parentheses here. Notice how I called the name of the function, print, and I followed it with parentheses, open and closed here. So when you use or call functions, you're often going to type the name of the function, followed by parentheses, and then some input. Some functions might not even take any input. You can call them like this, print, open, and close parentheses, and that would mean this function doesn't take any input, or in this case, I haven't given any input on line 3. But I have, of course, on lines 1 and 2. So to give you an idea of what these functions will do, let me go ahead and run the program. I'll type python hello.py down below to run this program top to bottom. So that is first we'll see the print function will run on line 1, and then on line 2, the second print function will run. So I'll hit enter here, and I should see, hello world, this is CS50P from top to bottom. So we've used these functions, but as a programmer, you might also want to create your own functions. And in particular, you might want to write programs that are composed of individual functions. Now, to define your own function, that is to tell us what code should run when I call or use the function, you can use a keyword called def, D-E-F, where def stands for define. So maybe, because this is the main function, I'm about to write the main function in my program, I could just call it main, def main like this. And I want to include an open parentheses and a closed parentheses followed by a colon. And that then says I have a new function that I've defined called main that in this case won't take any particular inputs. But now if I want to tell Python, or my program in particular, what code should be run when I use this function, I need to indent those lines of code and put it inside this definition here. So why don't I take these two prints, and put it inside of my function called main. I'll indent both of them and move this back up to the top. And now I have defined, again, a function called main that doesn't take any particular input, but it does run these two functions. First the print on line 2, and then the print on line 3. So now that you've seen how to define a function, you could think about how or who defined the print function for us. Because right now we're saying print hello world, but what does it mean to print? Like what goes into printing to the terminal? Well, it just happens that the Python developers defined what happens in the print function elsewhere in the Python library, which you'll learn more about as we go through the course. But for now, you can just kind of know that you can use this function, print, but somewhere else, somebody before you has defined it and allowed you to use it in this context, just like I've now defined a function called main here. So let me go and run this program now. I'll say python hello.py, enter. I don't see anything, which is maybe surprising if you're new, because here I said I'm going to define a function called main, and within that function I want to do the following. I want to print hello world, and then print this is CS50P. But in Python, defining a function is different from running it, or this technical term called calling it. So I've defined my function called main, but I haven't called main. And by convention, I can do that using two new lines underneath my definition here, and then calling main. So I'm going to now run whatever I've defined as part of my main function here. I'll type python hello.py again, hit enter, and now I should see hello world, this is CS50P. Because this program is read top to bottom, it will first define a function called main, it will then say what functions compose that function, which function should be run when I call this function, and then down below, I finally actually call it on line 6. And so now, in this case, you've seen that my entire program is really kind of a function. As you go off and build new and better programs, you'll see that a lot of what you're doing is just writing things that take inputs and produce outputs, and those things are called functions.
Okay, so he discussed the functions like the inherent functions and like for example print. And there are certain functions like you can create anything by defining certain things as a function. Okay, let's go down, variables.
Okay, now in this short, we're going to take a look at one other building block of our programs, in this case, variables. And variables can be containers for some value that can change over time. So let's say I want to make a guessing game where the user can guess some number, and I'll tell them if they guess correctly or incorrectly. Now, it would be probably worthwhile to have some way of referring to the user's guess in my program. What number did they guess? And that's a great use case for a variable. So I want to make a variable in Python. I can do it by typing the variable's name first. So what's a good name for this variable? I might say something like just guess. So guess is the name of our variable, our container for the value that you're going to give us that we can store over time. So I'll call this guess here. And now I want to assign this container called guess some value, some number to hold as the user's guess. So let's say the first guess by the user is 10. I could store that value 10 by saying guess equals 10. And this equal sign doesn't necessarily say that guess is equal to 10 now, but more so that we're going to assign this value 10 to be inside the container that we're going to call guess. And now that I've done that, if I want to print out the guess, see what is inside this container, I can do that on line 2. I could say print guess. Now I'll say python of guess.py, and I should see 10 printed back out to me on the screen. Now, variables become really powerful when we combine them with things like functions. So let's try to make our own function that can get a user's guess. Now, one way to do this is to define some new function. And I might call it maybe like get guess. So I'll say def, define me a function called get guess. And it will take no inputs. But I'll then, inside this function, define myself a variable called guess. And I'll set equal to 10 here, just like I did before. And now I'll have that function return to me, as we saw in the return value short, this guess here, return guess itself. Now down below, I could say print get guess, just like this, which will run the get guess function, and then print the return value, which in this case is this variable called guess. So I'll say python of guess.py, and I should see 10 again. Now, it would be not a great program if the user had to open up guess.py and change their guess every time. So ideally, we would actually let them type in their guess in the terminal. And there's a function for this called input in Python. So I could set this variable, instead of being equal to the number 10, equal to whatever the user types in at the terminal. And I could say input, just like this, enter a guess. So now, before we assign this variable called guess a value, we'll run the input function. We'll print this text, enter a guess, and whatever the user types in will be now stored in this variable called guess. So let's try it. I'll say python of guess.py, and now I'll type in 20. And I should see I printed out 20. So that means that the return value of get guess is 20. What if I did python of guess.py again, and I entered 5? Well, in that case, it seems like the return value of get guess changes as I type in numbers here. So that's pretty handy for me. Now, what if I also had a way to compare the guess against some actual number here? Well, I could go ahead and define the main part of my program and get working on the functionality to check the number that the user actually gave us. So I'll say define the main function now. And inside of here, I'll maybe make a new variable called guess equals, and then say get guess. So now what's going to happen is get guess will run, and its value will be assigned to the guess variable here. Now, one question you might have is that it seems like I'm using these variables guess multiple times, and isn't that something I shouldn't be doing? Well, it turns out that because these variables are inside of different functions, they can be used in different contexts, in which case they will never refer to that same value. They can be separated, let's say, by these two functions. So now I'll go ahead and I will run Python of guess.py. Actually, before I do that, let me go ahead and actually run the main function down below. And let me try to run Python of guess.py. And I'll see enter a guess. I'll type 10. Nothing yet, but I haven't really printed anything over here. So I'm going to go ahead and now print the guess I got from the user. And now I see 10 overall. And again, this works because these two variables are inside of what we call different scopes. This variable is inside the scope of this function, get guess, whereas this guess variable is inside the scope of this function called main. So let's go ahead and actually compare the number here. And the number I'm thinking of is a number called 50. So I'll say if guess is equal to 50, why don't I go ahead and print correct, just like this. Or let's say maybe the guess isn't 50. In this case, I'll print incorrect, just like that. So now this is our program in its entirety. And this here simply is a question we're asking. If guess is equal to number 50, we'll print out correct. If it's not, we'll print out incorrect. So now I'll go ahead and I will run Python of guess.py, hit enter, and I'll say maybe I'm going to guess 50. But I get incorrect. So it seems like I typed in the number 50. But I wanted to check if guess equals this number 50. Didn't seem to see that it is that same number. Now, this is a bit of a tricky scenario for new to programming, but it's also one that kind of shows us different kinds of variables we can have. Now, it turns out that in Python, there are many types of variables you can have. One of them being like an integer, as in like this number 50 here, and one of them being a string, where a string is some collection of characters. And in this case, when I use the input function, I'm actually getting not the integer 50, but the string of numbers like 50. So to illustrate this real quick here, I'll say this is the number 50, but this is the string 50. And if I were to say, does 50 equal the string 50, I would get back that they actually don't equal each other. So this is an example of different variable types. And it's often useful to compare variables of the same type, because if you were comparing, like, let's say, the word cat to number 50, doesn't quite make sense. So let's try to actually convert the result of the input function to a whole number. And I can do that by using this function called int, which takes some text and converts it to, or at least tries to convert it to, a whole number, like 50 or 25, for instance. So now I will store inside of this guess variable, inside the get guess function, the number 50. And then later on, I'll compare that number 50 against number 50 down below. So I'll say Python of guess.py, hit enter, and I'll say 50, and now I see it's correct. I'll say Python of guess.py, and let me try now 25, and I guess incorrect. Let's say I want the user, though, to actually type in the, let's say type in like 50, for instance, or 10, just like this. That would be an example of a string, not some whole number, like an integer. So I could change my program. I could simply revert the int from this, and now it'll give me just plain text. And I could compare. I could say, is guess equal to this string called 50? I could check that. I'll say Python guess.py, and now I'll say 50, and that seems to be correct. I could say Python guess.py and guess 10, and that seems to be incorrect. So the type of variable you use often depends on the context. And as you go off and write more programs, hopefully you get to see how powerful variables can be and what type might best suit you for each scenario.
Alrighty, I think I'll stop it here and I'll call it a day. It's like 17 minutes something, but still, uh, from tomorrow I'll have to get back with a fresh brain because otherwise it's gonna be waste of the energy and time.